for joining today. And also at this point, a huge thank you also to the Stacks Foundation for providing the grant for the Jolocom-Stacks integration. I'm Joachim and the founder of Jolocom, and I'm here with my colleague Eugenio today, co-developer at Jolocom. And for those of you who have not heard of us yet, Jolocom is a decentralized identity infrastructure company founded in 2014, based in Berlin, and we are currently 13 team members. And at Jolocom, like where we come from, we believe in the concept of decentralization, that it requires us to build open ecosystem infrastructure to actually make the promise of decentralization a reality. And this is why we also engage in community building, standardization bodies, governmental think tanks, as well as Web3 peer projects, integrations such as Stacks. And one of the recent achievements, what's the next slide? Moving. One of the recent achievements that actually goes back to 2016 in its origin are the Secure Digital Identity Lighthouse projects of the German government. The project made us reach out to Stacks since we believe it would be a great opportunity to real market adoption for decentralized identity and Web3 applications in general. And just like some benchmarks, there's like 4 project consortia that are funded. Jolocom has been selected in 3 out of these 4 projects. There's a whole range of use cases, about 40 plus use cases across various sectors, which are a great opportunity for adoption. The timeline these projects are implemented is like over the next 3 years, just starting in a week from now. And there's quite some substantial funding behind those projects, which is about 60 million euros. And the underlying vision behind this project is actually to initiate open SSI infrastructure and ecosystem for this. So far, some background info, and let's take a look at Stacks. The Jolocom-Stacks integration proposal relies on W3C Stacks and decentralized, or for decentralized identifiers and verifiable credentials to eventually enable real world use cases such as single sign-on payment, along with sharing other verifiable information, just as in the before mentioned Lighthouse project. And a full description of our proposal can be found on GitHub. And the proposal itself consists of 3 milestones. And today we would like to take a look at milestone 1 and collect some valuable feedback from you. And for this, I would like to pass it on to Eugenio.
Thank you. Okay, then I'll begin sharing my screen in a second. I think you'd have to stop your screen sharing first.
Yes, I stopped screen sharing.
Okay, wonderful. So I will share my screen. You should be seeing a Notion document, but before we get started, I'd like to provide a bit of context, also introduce myself. So yeah, my name is Eugenio. I'm a developer with Jolocom. I've been with Jolocom for like 5 years now, and mostly working on tooling around decentralized identifiers, verifiable credentials, also mobile wallets and libraries, DID resolvers, and similar kind of mechanisms. And I have been digging into the Stacks integration on our team the most, I guess. So far, I've just kind of gone down a few rabbit holes and have to onboard the rest of the team members onto the progress. Yeah, I've been basically yeah, researching this topic quite intensively. So we had 2 calls already with Jude, where we got some feedback on, or like we basically discussed originally the scope of the integration and what exactly do we want to build and how should we build it, and also kind of highlighted some potential ways of actually building things out and achieving them. And I am on the wrong document. I mean, it's a relevant document, I believe, but it will also be linked in a second. So some of the original kind of initial discussion we had is kind of summarized in this document. We've outlined in high-level terms the 3 deliverables with some references to actual code deliverables and specifications we would have to be doing. And I guess, yeah, since we're talking about the first deliverable, the main kind of body of work or the bulk of work we envisioned here was basically trying to really basically figure out how a DID method could be built on top of stacks. And that task was not very complicated, actually. I mean, no, sorry. An existing DID method already is already there, actually. And that kind of helped us quite a bit in terms of like the initial discussion and the initial assumptions and requirements and some further things. I will share a link to the document that I'm currently screen sharing from. Oh, actually, sorry, pardon me. Okay, I guess I don't have access. I do have access to the chat. Yeah, okay. So this is the document that we're currently, that I'm currently sharing. And in this document, I tried to kind of capture our current state of thinking, some of the requirements and assumptions about the solution we want to develop, some details about the DID format or the DID stacks method, or the second iteration of this DID method, rather, some initial ideas about how DID resolution could happen, and some ideas around how deactivating a block stacks did would work. Also, I've gathered some open questions I've encountered as I was kind of studying the documentation and trying to think this through. But yeah, anyways, I think it would be useful, I guess, to take a quick look at the high level, like the beginning of the document, the high level section. So there are some useful links here. The first link is the decentralized identifier specification or the DID specification. So the scope of work actually for our collaboration is to define a DID method and a corresponding DID method specification document for a DID method that is anchored or based on the stacks blockchain. As I mentioned earlier, an existing DID method specification already exists for the first version of the DID method. And this solution makes heavy use and relies on the blockchain naming system, or BNS for short. At this stage, the blockchain naming system, the BNS actually is not implemented as, rather in the current iteration, actually the underlying implementation of the BNS has been updated to be a Clarity smart contract that is deployed on chain. Previously, the name records were actually written to the chain, and well, not all of them actually, but yeah. So a lot of the functionality when it comes down to resolution and a lot of the concepts actually do not change a lot because we are still building around actually the BNS as kind of the central component, but some of the sections that outline how the interaction with the BNS system, for example, for registering, anchoring, and updating the IDs would have to be updated to no longer reference the previous approach, but rather basically mention the relevant contract calls to the Clarity contract. But to not go into too much detail at this stage. So yeah, we have the DID specification, and then we have the method specification for the first iteration of the DID stacks method. I've also included a link to the BNS contract, source code, and the deployment, although I think these things are familiar to most people here, and also a link to the development milestones document that I've just shared. It basically contains the original high-level milestones, including some conversation, actually, and some very helpful feedback from Jude on some of the open questions and similar things we had regarding on how to move forward. All right, so so far so good as far as the useful links and the context is concerned. So I would like to start kind of by providing the large picture about some of the requirements. And not all of these things are strict requirements. Some of them are assumptions or maybe subject to change, but some of the things we've settled on when thinking about the second iteration of the DID method. So firstly, and I guess this might be fairly straightforward, is that a new DID method will be defined under the DID stacks v2 method prefix. This also, I guess we'll get to it later. I wanted to say about API endpoints for resolving these DIDs and further things, but nonetheless, basically a new DID method will be required and defined, and a new DID method specification document will be created. So analogous to the one that is currently published, but referencing the current implementation of BNS. And some relevant points here, I think, and one of the more interesting point that came up during our kind of initial discussion and scoping is that now with the BNS change, actually, we can make an assumption essentially, and that assumption is that one principal or one address maps to one. Actually, so before I get into these details, very briefly about how the resolution process is envisioned and how BNS actually fits in this resolution process. So DID stacks, DIDs are essentially backed by BNS names. This is a similar approach to the one in the original version of the specification. What this essentially means is that operations which update or register the DID, of course, are BNS operations, but also the resolution process happens via the BNS systems. So in this case, the smart contract actually. And the process essentially is, we'll get to this in a second, depending on the structure of the DID itself, the process can vary slightly, but the high level idea is that given an address or an identifier, which is part of the DID, we would like to query the BNS contract to basically get the names or the name records that are currently owned by this DID or registered by this DID. We would like to get to the zone files, and then from there we would like to get to the correct resource record, essentially get to the, this process is also outlined in the original specification, in the V1 specification, but get to the, basically get the URI for a JSON Web Token that is signed by the key, verify the signature, and return a DID document. This is a lot, but high level is essentially that we would use BNS, we would use the zone files, we would use the zone file hashes and the records within the zone files, and the signed content that is referenced within to essentially perform DID resolution. So the process of DID resolution is essentially mapping an identifier to a key in its simplest form, and the BNS contract is used to do exactly that, basically to map the identifier to the key that's signed and associated token. The original DID method specification references on-chain and off-chain DIDs in the context of DID stacks, DIDs. And the difference between these is basically how they are registered or how they are anchored. So on-chain DIDs are, well, anchored on the chain directly in the context of the second iteration of in the context of the BNS clarity contract. These are registered with the contract via method calls and contract calls, and yeah, can be resolved using the contract. Off-chain DIDs, from my current understanding, DIDs which are anchored, so to say, in subdomain files, or they are not directly anchored on chain, but a number of subdomain entries. Sorry, yeah, I mean, a number of such entries can be gathered in the zone file and published to the chain. So they are kind of checkpointed on chain, but the actual data and the actual signed, the actual key information and other things are basically being synchronized between the stacks nodes directly. But yeah, one assumption or requirement, I guess it goes without saying, is that we would like to maintain that functionality and basically be able to support both on-chain and off-chain DIDs. One thing we identified during our initial calls is that the method-specific identifier, or the namespace-specific identifier, sometimes referred to as well, Essentially, the part that follows did stacks v2 or did stacks v1 would have to be updated. So if we look at the first version of the specification, essentially a stacks DID is a combination of an address and an index. And this index value basically allows us to sort of pin this address to a particular name registration operation. So this corresponds to the fourth name that was registered by this address. With the change in the BNS contract, so we're starting using the BNS contract, moving away from the on-chain based approach. One of the things we identified fairly early that this argument no longer is required for on-chain names, where one name can essentially map to one principal. Yeah, this argument would not really be required. And feel free to stop me at any point or jump in with questions about the assumptions. Yeah, as I mentioned, I kind of did a lot of research on this. I've been kind of slow reaching out with questions, unfortunately. So I think some of these assumptions might not be very accurate, but in case, anyways, moving on, the next kind of requirement and assumption we've identified is that, well, this I already mentioned, that the new DID method would rely on the BNS Clarity smart contract for DID resolution. And the implications of this are that in order for a DID resolution step, or for the resolution to basically succeed and work, the address must have a registered name. So the address that is encoded in the DID must have a registered name. This would allow us to actually go for the BNS contract and find the corresponding signed token or the corresponding keys that are associated with this address. Another point that we have identified, so this kind of follows from the integration with the BNS contract, but also we've noticed a similar approach in the first iteration of the DID method, is that the life cycle of the DID is basically tied to the life cycle of the underlying names. There is a section in the current DID method specification which describes how a DID can be deleted, deactivated, and essentially it maps down to you have to relinquish control of the underlying name, either transferring ownership or transferring it to a different address. But the main kind of assumption here is actually that the life cycle of a DID and the validity of a DID is tied and bound to the validity of an underlying BNS name, and that when that BNS name is given up, the DID is no longer considered active or valid. And one point, this is not so much an assumption, this will be elaborated on later. It's maybe a consequence to some extent of the, anyways, the point here is that as it currently seems, this DID method would not allow for key rotation. So there's hundreds, literally 100 DID methods out there, 94, I think, as of a few weeks ago. And then they vary greatly in terms of the features they support and the functionality they offer. So some DID methods allow you to rotate the keys that are associated with the DID, and some do not. The ones that do not would, for example, be DID key, and others DID key is probably the most kind of canonical example. In the case of the stacks based DID method, because of some of the enforcement that would happen at the resolution step, it seems like the key that is associated with a DID cannot be rotated. So the DID would include an address. Through the resolution process, we would find the key that hashes to that address, and we would verify that that key is truly owned by the DID by verifying a signature that was generated by the key. But the enforcement that the key essentially matches the address, or the hash of the key matches the address, seems to prevent basically key rotation operations. So we'll probably get into that a bit later, or if you have the document, you can read down. Anyways, I would like to briefly jump into the next section, and then I guess really open it up for questions. Yeah, basically the next section I think outlines a few potential formats for the second iteration of the DID method for DID stack. So these are the formats for the namespace specific identifier or the method specific identifier. I included a code from the sort of first version of the DID method specification, which highlights the point I made earlier about the fact that in the previous iteration, each name in block stack has one or more corresponding DIDs, and each block stack DID corresponds to exactly one name. There is a further statement about the usage of the address and the index in the relevant section, but to basically, recap on this or to comment on this. The current namespace identifier essentially includes a combination of an address and an index. And the index is used to register, to indicate how many names have been registered by the address at that point in time, is to kind of pin it to a particular point in time. Our assumption that it's actually to really pin it to a specific kind of name or name record and the lifetime of that name. And during the resolution process, I think this is reasonably straightforward. During the resolution process, we would basically need to make sure that at that point in time, the key that is associated with the address, the key that is associated with the owner of the name matches the address. Are there any kind of questions or comments until this point? Something that I should address?
Are you looking for ways to do key rotation?
No, I was not looking for ways to do key rotation. The only reason I bring that up is because I've noticed a few. So I've noticed a few sections. So in the original DID method specification and in the BNS contract documentation, in both cases, we make references. We make references to basically transferring the name to a new owner to rotate the key. So I wasn't sure if that was, sorry, I should have had that handy, I guess. But there were references to basically the functionality where the ownership of the name, I guess I have them actually right here. Let's use that. Perfect. So this one is a comment on top of the name transfer function in the Clarity smart contract. And basically, I was wondering about you would send one of these transactions if you wanted to change your private key. But then I think also in section 4.3, there is a comment. Anyways, perhaps it's not worth going into it too much. So I was not looking for a way explicitly. I was just making sure that it's explicit, that would not be in scope, or that it's hard for me to envision how to do that right now. I go into more detail, a little bit more detail on this. I think this is actually the quote from the document. If the DID corresponds to an on-chain name, then the user must send the name transfer transactions to send the name to a new address. No, sorry. Oh yeah. Once the transaction is confirmed by the Blockstacks network, the DID's public key will be updated. So this was the key rotation kind of statement that tripped me off. But yeah.
Right. I was just making sure that it's understood that it doesn't necessarily mean the DID also has to change. In the original design, the public key hash you have in the DID is simply the hash of the first public key, but not the current one, and it never changes.
Right. Yeah, and that's so kind of I thought about that, and I think we could go into more details about that, because there's also the problem of course having a provenance log of given the last state of a DID and the public key, if they are not related in any way, if the DID is not a hash of the public key, or you don't have a series of kind of events or logs which rotated the key starting from the original one, then it's kind of difficult to trust these DID documents. It's difficult to know if if the key included is valid. But anyways, I think, yeah, this is outside of the scope at this stage. But thank you for the update. Okay. So yeah, in this section, I'm basically I'd like to briefly go over some potential structures for the next iteration of the DID, of the Stacks v2 DID. We've discussed one of these approaches in one of our previous calls, actually, so I'll briefly touch up on that. But anyways, I present just three approaches briefly and then contrast them. Yeah, basically when trying to figure out how to actually structure this block Stacks v2 DID, given that we don't really need an index anymore, the first kind of thing we reached for, the most simple approach was, okay, can we just kind of embed the address? Can we just use the address, have did v2 address? And the resolution process would basically be querying the BNS contract to find what names are associated with this address, finding the appropriate zone files and continuing from there. Actually, there is one important point that I missed in the assumptions. I kind of jumped to the key rotation point, but one assumption we have, or one idea, is that a lot of the resolution steps actually, when it comes down to working with the zone files and ensuring that the key is really associated with the address and verifying the signature and so on and so forth, a lot of these are not very different from what was implemented in the first version of the resolver. The way that we actually get the zone file record and the zone file, and so some of those steps are different because we're interacting with the contract. Some of the validation steps and such might be different as well, but a number of the resolution steps can hopefully be just employed. But yeah, anyways, moving on to just briefly the options for the DID structure. So yeah, we briefly explored the DID v2 sort of address idea. There is one point I'd like, so two potential issues here, but I would like to start with the second one because I think it's clearer, or it's yeah, a better starting point. So in this approach, it's hard to bind or basically we cannot really bind the address to a specific BNS name. So a DID like this can be created at any point, given that the address has a BNS name associated with, or like it owns. But of course, throughout its lifetime, it might transfer that BNS address to someone else, and it might register different names. And although the resolution could partially function, because all other further names that are registered by this address would actually be signed by the same key that corresponds to the address, if I'm not mistaken. What that means essentially is even if the name records, underlying name records change, the key associated with the address would not necessarily change. So that would not break resolution per se, but it removes this binding between the DID and the name. And it prevents basically the DID deactivation and some other use cases. It makes the system slightly more ambiguous. I would like to see, okay, it's not a very useful comment. And the second issue I had, or like the second problem I had with this approach when thinking about it, but this is, I think, just one area that I'm currently actually researching. I need to dig into quite a bit deeper, is actually what if this address belongs to, or like, yeah, what if this address is associated with a name that is registered off-chain? So if it's registered as some subdomain. I have dug through kind of a number of the code bases, but and I think I have links for that a bit later. But it wasn't immediately clear to me if I can use the BNS contract. I know I can use the name resolve function and resolve principal functions and similar, or just read from the maps directly to get the zone file hashes and other things for names that are registered on chain. Use a bit trickier to figure out how to do that for names that are registered off chain. If there is a very easy way to do this that I'm missing, then this approach could actually be explored further, perhaps. Actually, no, sorry. The second point is kind of a deal breaker. the second point is essentially the issue of the binding this address to a specific name record. I will jump to another potential structure, and this is one that we have discussed in one of our two scoping calls. And basically, in this case, we are trying to account for the binding with the name. We're trying to include an additional bit of information in the namespace identifier that also, like in the previous kind of iteration, basically pins or helps us kind of evaluate it in the context of a particular name. The proposal here was to essentially have the address and then append the block height or the chain tip at the point in time at which the DID was created. Right. Yeah, sorry, this references the previous point, got confused for a second. But the approach here, or the idea here, is to essentially have the address and then the block height associated with it. And during the resolution process, we would actually first resolve at the block height that is included, or at the block that is included in the namespace, and then, sorry, in the namespace identifier in the DID. And then we would essentially, and as part of this approach, we would actually have to define a very small, very simple BNS proxy contract, another clarity contract, which exposes just the functions that I mentioned, basically resolve a principal at a particular block or to resolve a name at a particular block. And these methods would essentially make a proxy call to the deployed contract, but making use of the add block function to evaluate the expression in the context of a particular block or a particular kind of chain state. Sorry, right. And the idea there was basically we can include in the DID, we can include the point in time where when the DID was created. As part of the resolution process, we would first resolve it at the specified block height, get the underlying keys and the name that was associated with this address at that point in time. And at that point, we could perform another resolution essentially, but at this time, not against a specific block height, but against the latest state of the chain, and essentially ensure that the name has not been transferred or revoked, that the name is still valid. The associated token, the associated profile and other things can update, but essentially the owner and the key associated must remain the same. So basically, yeah, in this approach, we try to get around the binding with the name by actually sort of pinning it to a particular point in time, and the name that was owned by that address at that point in time is the name to which the life cycle of the DID is bound. There are some comments about this approach and some of the potential, well, not necessarily issues, but I guess implications or outcomes of this. So the first one is essentially, if we take this approach, then we could have multiple DIDs that essentially map to the same underlying identity. Specifically, for example, if we have the ID stacks v2 example at block height 14,000 and then 14,001, if we assume that no operations to update, transfer, or revoke the name have happened during that period, if implemented this way, the resolver would basically return the same DID document for both, and they would underline the same kind of, so they would reference the same kind of underlining identity. And this might pose problems in some use cases. An example might be access control lists. I mean, this is just one example, but it is basically when you have to compare DID equivalence by the DID identifier, this might introduce a bit of ambiguity. I'm not sure if this is an actual like massive issue, or if this has some nice benefits and properties to it. I have not yet fully grokked it, but nonetheless, that's one kind of issue that might potentially arise with this approach. And like in the approach that I showed previously, but this might be just a gap in my understanding, it's not immediately clear how this can be used for off-chain DIDs. So again, if the address owns on some subdomain, it doesn't seem like that can be easily found out from the Clarity smart contract or from the Stacks blockchain API or the RPC calls to the Rust code. But I might very well be missing something here actually. So I will conclude, I think, with the last alternative kind of approach, and this is I guess as fairly straightforward or self-explanatory. So it's similar to the previous approach, essentially, where we try to somehow contextualize the DID creation and bind it to a particular name, except that in this case, instead of just providing a block height, we can provide a transaction ID. And the transaction ID that would be included here would reference a specific transaction that registered or updated the name, and this could be a name register or a name update method call. The idea would be that given such a transaction, we actually would be able to get a number of useful arguments like the namespace and the name, as well as the zone file hash. So in this case, actually, if we include the transaction identifier as part of the DID during the resolution process, the appropriate transaction can be fetched, and then maybe we can make use of the arguments that were used in that were included in the underlying method call, mostly zone file hash, namespace, and name, and use them as part of the resolution process. And this is, again, quite similar in principle to the previous approach. What I mean by that is that the resolution process is also kind of twofold. We are first resolving in the historical context at the point when the identity was created, and at that point we essentially established the DID name binding, and a further kind of resolution call would follow that would resolve it in the context of the current blockchain state and make sure that the underlying name, the underlying owner and associated keys have not changed. So this is fairly similar to the previous approach, except that because I didn't know how to get the off-chain DIDs or how to resolve those, this is actually helping in that case. So it might simplify the resolution of off-chain DIDs because the transaction referenced already includes a zone file hash, so it should be enough information for us to actually proceed with the resolution process, essentially. The point that I mentioned about sort of the binding between the namespace identifier and the DID. I mean, the downside of this approach is that we would be getting fairly long DIDs, but in many cases that actually does not matter. There are much longer DIDs out there. They're not necessarily supposed to be human readable, human friendly. But anyways, so this section basically outlines a few potential approaches towards an identifier format. I have, so personally, I feel like the second approach is the most straightforward for me, actually, just given my understanding of the tooling. But maybe the third approach, actually, with the block height could also be a very useful one if I'm really missing something about the off-chain DID resolution. So are there any comments or feedback on this section? And it's been a lot of information, or corrections also very welcome. All right. I will take that for a no, I suppose. Right. I think you'd be very helpful, and I think this goes back to actually me being a bit slow with reaching out. I think it would be helpful to maybe discuss these three alternatives in slightly more detail in a call to basically help decide for an approach. We would be happy with moving forward with the DID-Stacks v2 address transaction ID approach. We would also be happy with moving forward with the block height approach, but also some feedback on the kind of underlying assumptions, such as whether the DID should be bound to a BNS name. And I mean, on the key rotation, we already have brought that point up. So any feedback on those assumptions or corrections in case they're incorrect is also welcome. I'm finally in the Discord channel actually, so I can probably, yeah, get carried away there. But anyways, yeah, this is the first kind of, oh, sorry. No, never mind. This is the first kind of section of the document. And in the second section of the document, I have tried to outline the DID resolution process. I think the deactivation of a DID we have sort of touched up upon already to some extent, specifically that it is bound the lifetime of the underlying name. Right. So when we get to the resolution process, sorry. So I've tried to outline in sort of like high level, my current level of understanding. I think there are some gaps here. The process for actually resolving one of these DIDs. I think the high level approach, as I mentioned, is we are basically performing a twofold kind of resolution. First, in some historical context, either using a block height, an add block, or by passing a specific transaction that actually anchored the DID. And then the resolution process is essentially resolving the record in sort of the historical context, and then resolving it again in the current context to ensure that it has not been revoked or deactivated. I've generally, so unfortunately at this stage I have no running code, but I'm fairly familiar with most of the code bases, I guess, by now. So it took me a little bit to really onboard myself onto everything. One area that I'm currently actively actually, probably the last area actually I'm currently actively trying to figure out is the details and the nuances of the zone files and Gaia, and how to fetch zone files using zone file hashes. I found some relevant code for that, but nonetheless, it's a little bit still would take a day or two to put together. But the DID resolution process here essentially outlines the twofold approach as well. And this one is based on the transaction ID basically approach. This could be again the block height. The block height approach is referenced here in older nodes, and it's so largely similar, except that we start with a few proxy calls at particular block heights to get the required information to continue with the resolution. In the approach based on transaction ID, that information is fetched from the transaction that is referenced by the transaction ID. But the general process, and yeah, this is also one area I'm actively actually improving and working on, probably the more underdeveloped area. So the high level kind of concepts and mapping to stacks names and further things are more or less figured out, I believe, but the nuances of the resolution step and exactly how to actually parse and fetch zone files are still something I am figuring out. And yeah, I mean, I think can also reach out for help there. But the resolution steps in this case would be to basically separate, given the DID, would be to separate the address and the transaction identifier, fetch the transaction reference by the transaction identifier, and basically get the name, namespace, and zone file hash values included within. Retrieve the zone file associated with the zone file hash. And this is, yeah, one question, like this is one open question I currently have, I guess, about how this retrieval can take place. But I have, anyways, I have since actually found some relevant code, but maybe we'll not get into that too much. But essentially, we would like to get so from the transaction identifier, we can get the zone file hash, and then we would like to retrieve the zone file using the zone file hash. And then we would want to find the appropriate record in the zone file. And I think, yeah, when I say that this is one area that is probably a bit underexplored by me, is also because I guess I was lucky somehow. I was just never really exposed to DNS in my life, like DNS records and similar things. Anyways, like regex, but anyways. So this is stuff I'm still kind of grokking to some extent, but the core idea or the core process is that we can basically find the appropriate entry in the zone file, which basically references so pardon me. I was sure I had some, anyways, I had some examples here, but you essentially parse and verify the zone file, you ensure that the origin is correct, and then ensure that the owner matches. This is one kind of open point I currently have. But anyways, and essentially in the zone file, there's a URI, basically resource or directive included, which points to an HTTP endpoint. So basically the resource record that is included, the URI resource record that is included essentially encodes an HTTPS URL. And that HTTPS or HTTP URL essentially points to an endpoint that can be queried to get a document that looks as follows. Okay, well, this is terrible for sharing, but it's okay. To get a document that looks as follows, this document has, or like this JSON Web Token. I mean, we have both the encoded JSON Web Token, the decoded JSON Web Token version, but the key elements in this token, and this is really useful for actually establishing the relationship between the public key and the address, and this is essentially where we actually get the associated public key from. Is so that the most important areas, of course, are well, all of them, but like the public key and so the public key that's referenced under the issuer and the subject fields. The JSON Web Token also includes an associated JSON Web Signature, which was generated using this key over this content, and an additional kind of enforcement. These steps are actually described here, so the validation steps for this document. The first one is basically that ensure that the keys are correct, so ensure that the public keys essentially match to hash to the correct address. In this case, actually, this would also be the address included in the DID that we are resolving. One assumption I have is that these two should match. It's not explicitly mentioned, but my understanding is that both of them should actually hash to the correct address. We should also, I mean, we also have to verify the signature on the JSON Web Token at this stage to ensure that this key is really owned or like was really used in this context. And at this stage, so once we have performed the historical resolution kind of step, as I refer to it, at this step, essentially the key material that is associated with the DID at that point in time is known. So we have the public key, we have the DID, we also have some additional information. And we can actually just construct a DID document, a spec compliant DID document based on that information. But of course, first we need to ensure that the name is still valid, that the DID was basically not revoked. And that basically happens starting from step 6, where again, we have the name and the namespace. And this is a helpful aspect of it as well. So from the transaction ID, we were able to extract the name and the namespace with which the zone file and the zone file hash is associated. So this actually makes it easier for us to call the name resolve function on the deployed BNS contract to get the current state of the name record, to get the current owner, to get the current public key. And we essentially kind of repeat the resolution step when it comes down to fetching the zone file and basically finding the correct records, fetching the keys and verifying them. And once we ensure that that resolution step is, so once we ensure that the keys have not changed, that the signature is still valid, the owner has not changed, we can actually complete the resolution process. And at this point, we can actually generate a DID document based on the public keys and the identifier yeah, we get from the resolution process. Sorry, the public keys, yeah, and the DID that we get from the resolution process. We also have at this stage the BNS name that is associated with the DID. I mean, it doesn't seem like that can be easily included in a DID document without specification compliance issues, but there is the opportunity to also resolve that, sorry, return that as part of resolution metadata during the resolution process if this name is actually useful or important. But anyways, yeah, this is quite a bit of content. I mean, I hope I've kind of generally outlined the scope of the work, some of the kind of core concepts and ideas like the binding to the BNS name, some of the potential alternative implementations and ways to actually get there, and some of the trade-offs between them. Yeah, and then I've also demonstrated my knowledge of DNS. Yeah, the kind of next steps or the current status as far as development and familiarizing with tooling is concerned, I'm generally comfortable with writing, deploying, interacting, and so on with Clarity smart contracts using Stacks.js libraries. Yeah, luckily there's quite a bit of tooling there. The one area that I'm currently struggling with a bit is the zone file related functionality and documentation. I was able to find some examples of zone files and similar things, but I also wanted to find, anyways, what I wanted to say that, I mean, I've also identified some fairly useful code in DNS related branches on Stack.js and blockchain API. But anyways, I think to not get into too much detail there. So generally the proof of concept for the resolution process kind of hinges on the resolution of zone files and such. I can get to the point where I have the zone file hash and similar things, and then other aspects after that are also relatively straightforward, but the resolution, parsing, validation of zone files is currently the area I'm focusing on or trying to figure out. So thank you for listening, and I hope this was somewhat interesting and not too painful for the people that are very familiar with the Stacks stack. But yeah, again, questions, feedback. I think the document is already shared in the group. Questions, feedback. I'd be very happy to also discuss some or all of these points on the Discord channel now that I'm finally there and I've made a public commitment. Anyways, so yeah, glad to take questions. I will stop my share.
So Louise, I guess, suggested to discuss briefly next steps, because we ran a little bit over time. Really apologies for this, and also for this.
No, it's okay, man. No worries about it. It was I mean, I'm not really technical, but I feel like there was so much information in it. So what we can do at the foundation is probably circle out the recording of this to everybody that we know that's currently working on the IDs. For example, I know the team in here, the Connect team is very much open for like, if you have like a new integration or like proposal, they're more than willing to give feedback. So that's like one of the next steps for us. And I'm just wondering what are the next steps for Jolocom and how the community can actually help in order to speed this process up. Do you need more feedback, or do you need more like people to look into your code base? Yeah, I think finding those would be great.
So yeah, thank you for the question. I think like the first kind of next step really would be to, so we have a few open questions in this document that I think maybe we can also discuss on the community channel or yeah, directly. But the first kind of milestone would really be to, or the first next step would be really to have a proof of concept that can undergo the resolution process essentially. This is the main idea of the first kind of milestone, is to really figure out how this can be built in a sensible way on top of Stacks and have a proof of concept that essentially shows the integration. But the following milestones are much more kind of intensive when it comes down to potential integration work. So there is the third milestone where we essentially integrate. So actually, sorry, so we develop the resolver in the first milestone, and the resolver that we want to develop, it will satisfy an interface which can be integrated with some of our tooling, but also some tooling that is used by the SSI community, the universal resolver. There's a few libraries and modules, but essentially, a lot of integration work will happen there probably, but at this stage, really the next step would be to clarify some of the open questions and misconceptions I might have about the resolution process, about the usage of zone files, and to basically open source the proof of concept implementation, get some feedback and contributions. In the next milestone, we would like to actually help integrate this in a number of Stacks relevant repositories. I mean, we discussed, I think, Stacks.js as a new package within Stacks.js to handle the ID resolution. And then also when we look at Stacks blockchain API, there's currently endpoint, a REST endpoint for resolving V1 DIDs. So a similar REST endpoint would have to be developed for V2 DIDs. And there's going to be a lot of mingling, I think, with the kind of Stacks stack and the intended use cases and similar things at this milestone. I think if we can get started with that earlier, that would be great. So to summarize, I would like to basically get the proof of concept going, to open source the repository in parallel also in Discord, basically, or directly communicate some of the questions we have and some of the open kind of uncertain, some of the assumptions we are uncertain about. And then I think as we mature this code base, there will be work related to integrating this with a number of relevant repositories. And there, I think feedback or kind of requirements from maintainers or from people that actually intend to use this DID method in the context of their use cases would be quite valuable. So yeah, I think really actually sort of getting an understanding of how people intend to use this DID method, of whether the functions that we are providing here satisfy those requirements with terms of key rotation and similar things. But yeah, sorry, going for a bit more over time. Does this answer the question, or?
Yeah, no, that's perfect. No, I took some notes down because that's all I can do on this call, just take notes and forward it to the right people. And I think that's pretty much it for today, guys. Do you have any more questions for the Eugenio and what came from Jolocom? I can spare 2 more minutes, just like to be cautious everyone's time. If not, we can always do a discussion on Discord. Everybody's there. I'm always there. So if you have any more questions to Eugenio and Joachim, just feel free to reach out in Discord. And that's pretty much it for today. If nobody has any questions.
I think my colleague Mina is also in Discord. I'll ping him there. So
yeah, perfect. I think I'm gonna circle back with Joachim, just like to get your like Discord username. I'm gonna pull you into our Discord. So I think, you know, one of the best ways.
Thank you for this. Yeah, I'm actually using Discord. I don't know why I had trouble today joining, so sorry again for this. But again, thank you also for this opportunity and for the call and everyone joining. And yeah, looking forward to continue the conversation and discussion on this.
Perfect. Thank you so much, and have a nice day, everybody.
Yeah, thank you too.
Bye-bye.
Bye-bye.
bye.